So very good noon, and my time is up to 12:25. I will stop by that. So the task which I was speaking about in the morning is especially for the students and the teachers who have come here. The task is like this. Those who have come here, there is a very big community who could not come here. So each of you should be a messenger to them and deliver the salient points which you think they are quite important. And if each of you can reach around 200 and inspire them, each of them, your secondary targets to generate tertiary resources, like a chain reaction, it should go. Now, it is very important time through which we are going through, and it is very important that we are meeting today because India has envisioned a very big picture of space. That is the year 2047, which will mark the 100 years of India's independence. Will also have accomplished two big goals. One goal is to have India's own space station, like International Space Station, which we call the Bharatiya Antariksha Station, and Indian astronauts will land on moon with Indian technology, do science, and come back safely to Earth, all with Indian technology. Now, if you see these two big visions, based on whatever we have already achieved, there are some intermediate steps which we have to do. And in these intermediate steps, we are getting ideas and wisdom from the rest of the country. We are also having a close watch of what is happening internationally. And science is not in isolation today. Science is connected with geopolitics. Science is connected with different other frontiers. So, keeping in view, not living in an ivory tower or some so-called fool's paradise, let's be practical and let's prepare for the next few years. Now, I have done one back of the envelope calculation. The calculation is like this. In the x-axis, you plot time. In the y-axis, you plot enthusiasm and experience, professional experience. So what will happen? Suppose you join a job at the age of 24 or 23. The enthusiasm curve is maximum in the beginning, and then it comes down almost as a polynomial or exponential, whatever, with time. The second graph, again with respect to time, the experience, it is less to start with, picks up, and remains almost stable, doesn't have much increment with time. Now, if you have to do a good work, a very strong work, impactful work, what you need is a product of these two, your experience and your enthusiasm. Now, if you multiply these two parameters and plot against time, you are going to get a bell-shaped curve. In the early years of your profession, the product will be very less because your experience is less. It will pick up. There will be a plateau and then it will fall. It will fall because your enthusiasm will fall. Statistically, this is the case. I'm not telling about the outliers or the exceptions. Okay. Now, if you see why does it fall, if you draw some calculation of a full width, half the maximum, we say, okay, take the maximum and take 50%, then see where do these lines cut. This happens at the age of around 35 to 50. You have quite a good experience, quite a good enthusiasm. Now, if you see, if you back calculate 2040 around, come back at the time of 2040, 2035, 37, who all of the people, they will be at the age of 35 to 50. That is, who will be there, who will run the show. Some of them are sitting in this room. That is how the mathematics is. And it is also important to tell that we speak about being good leaders. First requirement of becoming a good leader is a good follower. And I can tell you, I can offer myself as a good follower. And if you don't know how to follow, you cannot lead. Okay. After having said this, I will tell you, while India envisions this, India has created a good ecosystem by virtue of the following things. Number one, the national education policy, which has been rolled in year 2020, which emphasizes skill-based education system. There also has been space sector reforms. Many of you who follow newspaper and social media would know. Space sector reform means like this. You will not know, we will know. When we were young, very much young, we had only Indian Airlines or Air India, whatever, to fly. Today you have Indigo, you have SpiceJet, you have go on naming them, so many flights to choose from. Right? There was a time when ISRO was only running the show. There will be a time when India will jump with its own might. ISRO is the space agency. There will be academia, there will be industries, there will be startups to join might with the orientation of the space mission. This vision is being created by whom? The academicians of the country, the engineers of the country, not only from ISRO, they are coming from everywhere throughout the country. In some other occasion, I can tell about all this effort which have been done. But let me be very focused on what I want to tell you today. See, today when I am speaking with you, it is very important to note that today India has been the first country to have done a few things. Number one, we have soft landed to a region of the moon which has not been landed so far. The question is, so what? This requires discussion. Only takeaway on this is, where you are landing, wherever you are doing scientific experiments, has got a scientific importance. So far, the moon landings, whatever have happened, sample return missions, whatever have happened, they all have happened in the mid latitudes and the lower latitudes of the moon. But when it comes to the physics of the moon, maybe later on when we get some time to discuss, I can tell. For the time being, we take this message, especially if you want to convey others. Landing to the southern high latitudes of the moon has got scientific significance enormous, which has not been the case in the lower latitude landing. India has been the first. Going to the Mars for the first time in the first occasion, that is one feat. In Chandrayaan 1, we have sent the lunar impactor, right at the pole of the moon. That is the human's first man-made object, human-made object from Asia, and which is studied for the first time. Many aspects. This we can go on talking. There is no end to it. I will not waste my time on that. Today, my emphasis should be on the future. There may be other feats also. If you know, if you are enthusiastic about it, it's good. If you don't know, please note down, tell others. We also tell that today we are the third space agency after ISRO and NASA to have sent the Aditya L1 named dedicated solar observatory, which is studying the sun 24/7, balancing itself between the earth and the sun without being sacrificing itself to either, in a very peculiar orbit, which is a non-Keplerian orbit. Keplerian orbits are all planar orbits. You can draw a Keplerian orbit on a plane of paper, right? A non-Keplerian orbit is like a rubber band with a twist it. And it has got its own difficulties in flight dynamics. So, and also after you have achieved maintaining the orbit and lot of good science. So that we are third agency. We are the second agency to have sent one astronomy observation, which also does something different what the others have not done so far than NASA, one mission. our XQSat mission has got the capability to study a special property of the electromagnetic wave called polarization. You know, polarization is a property of the electromagnetic wave. The electromagnetic wave has got electric field and magnetic field. They're perpendicular to each other. And when they propagate, the direction of motion is perpendicular to both the electric and magnetic field. That we know. Polarization is the direction of the electric field vector. And if it so happens that beautifully combine the hair, you're combining the electromagnetic field such that you're forcing the electric field vectors follow a particular orientation, you have polarized light wave. And that doesn't happen naturally. But naturally, whatever degree of polarization happens in astronomical sources, they carry some message, which the other techniques like simply identifying what are these frequency components or what are the fluctuations, we say timing, that cannot doing. It tells you about what is happening inside the magnetic field structure of the source, or when the light is coming through a medium, how a magnetic field is modifying the plane of polarization. All these things inside you can tell. India is the second country to have sent such a mission. We should be proud about this. Now, friends, before I go to the future, up to 1220, 1217, I will speak about the good science which has come from Aditya L1 and Chandrayaan 3. Take this message out. See, we know that the sun is a ball of plasma, no state of matter. Plasma is very unstable because plasma is a soup of charged particles, and charged particles have got magnetic fields when there is motion. These magnetic fields affect the charged particles, and the effect of charged particles disturb the magnetic field. And in this dance, part of the plasma becomes unstable. Plasma is always unstable. They become unstable to a certain extent. Some of them may leave the sun and come out. We call it a coronal mass ejection, a mass which comes out of the sun. And there are associated events where high energy radiation also comes out of the sun. Now, if we have to see something is coming in the space, we all are interested to know how this is going to affect the Earth and the Earth space assets. We say our satellites are going to be affected. We say our power grids in the higher latitudes are going to be affected. We call it as a space weather. But have you not thought that knowing how they are originated, what is happening at the source when something is coming out of the sun is also important? And you can do it only if you can see very close to the sun. If you have a 5 rupee coin or 1 rupee coin and cover the solar disk, you will be able to see the outer aura of the sun, which we call the corona. Make the disk smaller so that the angular distance would cover only the solar disk. Okay? And then a small part of sun is sacrificed to the space. What happens there? That was discovered by the Aditya L1. The discovery was there was a sudden dimming of the corona, 50% brightness dimming, as if it was very sad that a part of the sun is coming out. Who all were left behind were very sad. They were very chaotic. That part of the corona, and they observed that the part of the corona flung away from the direction, away from the Aditya L1 spacecraft. The information has come. What happens in the sun when something comes out inside? Then the sun has got multiple layers. We are going to that discussion. Chromosphere and the photosphere, which has got some visible significance to the sun as we know it. These can be studied. The energy transfer can be studied in the ultraviolet wavelength. And is it not magical if we could have a magical telescope which can see the entire sun together in ultraviolet, see what is happening there, and as if you are watching that energy which is coming out of the sun, Do you know that energy which you are seeing to penetrate out from chromosphere, photosphere, they have originated their journey millions of years ago in the core of the sun? They do a lot of things in sun's layers, and it takes million of years to come out and surface. And you can see them in ultraviolet what is happening. Our Aditya L1 mission has, for the first time, imaged the entire solar disk in the near UV wavelength, 200 to 400 nanometer, found out that physics. Then, coming to, there are many. Chandrayaan 3, let me tell you, today in 2025, you are not going to be surprised if you see in your local market a very good object which has come from Kolkata, or a very good object which has come from Delhi, Tamil Nadu. Why should we wonder? Because there are transportation, there are aeroplanes they can bring, they can everybody will get everything today. But suppose we have landed in one region of the moon, okay, and you find something which has come, we have had evidence about that, other side of the moon, where there is a big excavated region, not human-made, called South Polar Aitken Basin, where a part of the mantle of the moon is exposed. From there, some material you find at the Shakti point where we have landed. What does it mean? It means that when moon was young, at the time, it was a ball of fiery magma. So there have been lots of hypotheses about this, how much of this moon was magma. It's called magma ocean hypothesis. Number one, Chandrayaan 3 mission has validated the lunar magma ocean hypothesis for the first time. Number two, in this process, Chandrayaan 3 mission has shown that some materials which are characteristic to the South Polar Aitken Basin has come to the region where we have landed, the Shakti point. This takes about a lot of energetics happening for material transport from in the early phases of moon's evolution. Because there are many, I can go on talking, but these 2-3 information if you carry, well, write Facebook articles, LinkedIn articles, tell your peers. Okay, now, 10 minutes. What's in future? We speak about a few missions. Chandrayaan 4 mission. We speak about Chandrayaan 5 mission. We speak about the Venus orbiter mission. Chandrayaan 4 mission is going to be a sample return mission, where we are going to bring some moon sample back from a region where from humankind has not got any samples so far. Ideally, it should have samples from all the parts of the moon. That doesn't happen. It might happen someday with a lot of coordination. Some of you might initiate and do it. Leaving that apart, we are going to go to some region of the moon to get sample which has not been got so far. Number one. Chandrayaan 5, NUPEX mission is about something very exciting. Do you know there are regions in the solar system where time has been stopped? Time has been stopped. What is time? Flow of events. In order to have events in motion, what we need? You need energy and time. The primary source of energy in the solar system is the sun. If you envisage some region in the solar system where the sunlight has not reached since the birth of the solar system, energy has not been deposited. When energy has not been deposited, temperature has not increased, energy has not come. When temperature has not increased, entropy has not changed, right? Entropy, time, direction of time flow, arrow of time is entropy, linked to energy. Energy is sun. Some regions are there, solar light has not reached. Mid-time, if I tell you, there are some regions in the solar system which are like this, and they're amenable to human exploration. Human can send robotic exploration there. Won't it be fantastic to imagine such a mission wherein you can find some evidences of all the chemistry which was happening in the solar system? These are not the initial condition in chemistry which has driven the evolution of the solar system. That kind of a mission is Chandrayaan-5 and LUPEX. LUPEX is the lunar polar exploration, and it is another name for Chandrayaan-5. These regions are the permanently shadowed regions which are there in some of the polar regions of the moon where sunlight could not enter through the bark of the solar system. That will give you the important information of the volatile materials which have governed or defined the initial conditions of the lot of chemistry which happened in the solar system. When we studied chemistry, chemistry is all about creating new things from certain things. That's how it manages to keep some difference from physics. At the end, everything is physics. And I say my personal perspective, physics is also not fundamental. There is a clear difference to it. We will not tell about those. Chemistry, creating new things. Today you see, after 4.5 billion years of this formation of the solar system, Earth is different than Moon, Moon is different than Venus, Venus is different than Mars, they all are different than Jupiter, Saturn. Some of them have atmosphere, some of them have thick atmosphere, some of them have no atmosphere, moderate atmosphere, some of them have intrinsic magnetic field, some of them have, because of their atmosphere, some of them are getting ionized. The ions are interacting with the solar wind, ionized particles from sun, and giving rise to some artificial magnetic field. We call it induced magnetic field. Different. But don't you feel excited when you think that all of them started 4.5 billion years ago at the same time, same way, same conditions, same gas of cloud of gas and dust collapsed under strong gravitation, caused energization inside, fusion started happening, debris, or around 0.1% debris created all the planets and other members of the solar system. 99.9% have gone to make the sun only. And those, they originated from same dust, same cloud. Now Moon is not like Earth, Earth is not like Venus. There has been an evolution. So, how to connect? LUPEX mission will tell you about the early conditions of chemistry, and once you study Moon and Venus, and we have studied Mars, also we are going to study Mars in another mission called the Mars Lander mission. They will tell how different they are, and at the end, we are going to connect in a subject which is known as comparative planetology. Comparative planetology is like comparative literature, where you study the different languages, linguistics, features, the origin, evolution of language, how they connect, how one language has been enriched by the other language, like this. Similar thing, same thing goes for planets and other members of the solar system. Despite having started together, how they are quite different. So that is comparative planetology. Apart from these missions, there are also missions which are being envisaged to study the exoplanets, the planets which are in some other solar system. And I don't know how many of you know. If you don't know, don't forget to tell others. India has the credit of several exoplanet discoveries using ground-based telescopes known as IIRS, which is situated under Mount Abu under PRL, Physical Research Laboratory. Many exoplanets has been discovered by us. Us means you and me. So, and we are planning to send studies going on to study from space exoplanets. Whatever discovery we have made so far from ground systems, they have their own limitations. But at some special region where sun will be never seen in the shadow of the earth, that point will forever remain under the shadow of earth. Sky will appear dark and with trained eyes of the instruments beyond the capability of human eyes, aided by human intelligence, India's mission very soon will also see different planets. Some of them may be habitable, who knows? Some of them may have some other forms of life, some other forms of intelligence, who knows? Okay, these kinds of missions are all lined up. Currently, when I am speaking with you, the approved missions are only the Chandrayaan-4, Chandrayaan-5, Venus orbital mission. Mars lander mission is in the stage of getting final approval. I have spoken about this exoplanet mission, which is known as ISRO. There is another mission which is getting ready in terms of maturity. It's called Disha. Disha mission is a mission where in the Earth's upper atmosphere will be studied with two satellites. One satellite is with the low inclination. Another satellite is of high inclination. Both will be around 400 kilometers altitude. They will study when some effect from the sun reaches the Earth's upper atmosphere, what are the changes happening. Why two satellites are needed? They are needed to discern between the latitudinal and the longitudinal effects. And many of you know that sun exhibits a cycle of 11 years of its activity. Presently, we are going through a phase of high solar activity, and at this point of time, IIRS is working. And next 4 to 5 years, we will see activity will come down, come to a trough before it again picks up. It is a very good opportunity for India or the world to study what happens when the range of the activity changes from high to low. And IIRS is studying, won't it be good if we have our Disha kind of a satellite also? There is also another one which is in the thing. So to conclude, these kind of activities have fostered a lot of national cooperations and international cooperations. Today, internationally, we are respected. We don't go for asking. When we ask, we ensure that we have something to give. So that is taken care. And also, India is a strong advocate of the sustainable space exploration. A few aspects of sustainability include, number one, space debris management. It has already started, many satellites have been brought back, Indian satellites have been brought back to the Earth without allowing it to remain defunct in space. Second activity which is happening in the country is the green propulsion system, wherein we are not jeopardizing the marine biodiversity also, but does not belong to the human beings only. And there are many, I can go on speaking, but let's take the task, which others, whatever points you have taken, you spread like a forest fire, wildfire, you spread. That is the thing which you have to do. Thank you. That's all.